Okay, level 2 in 3.1 is factoring without a greatest common factor. So what you did in level 1, don't worry about it in level 2. That will come back and we'll put it all together for level 3s. And then a difference of perfect squares. So if you look at this gray box, it says if you multiply x plus 1 times x minus 3, and you do the double distribution or the box method, you would get x squared minus 2x minus 3. So if you then go backwards and factor that, your factored form would be x plus 1 times x minus 3. So that's really what factoring means. We're kind of undoing that multiplication and getting back to the original problem. Now for sum and difference of perfect squares, again, the same thing. If you're multiplying x plus 4 times x minus 9, you'd multiply it all out and you get x squared minus 16. So if you were given a problem where it was x squared minus 16 and you were asked to factor it, you'd work backwards to get to those two factored forms. And we'll work through a couple examples on how to do that. So what we want to do first is look at these set of numbers. We have the product and the sum. So we want two numbers that are going to give us a product, or two numbers that are going to multiply to get to negative 36, but then add to negative 9. If we multiply, we know that one number has got to be negative and one number has to be positive. So keeping that in mind, when I'm looking for the sum, I know the larger number has got to be the negative number. Now, just thinking of products of 36, you could do 1 and 36, 2 and 18, 4 and 9. You can do a bunch of different combinations. So if I'm looking for products of 36 that add to 9, I know my two factors have got to be kind of far apart from each other. Well, I know that 12 times 3 gets me 36, but which one has to be negative? Oh, 12 has to be negative in order for this to equal a positive 9. So this is going to be negative 12 and a positive 3, because if we multiply those, that's going to be negative 36, but if I take negative 12 plus 3, that's going to equal negative 9. So for the product, you've got 48 and 14. So product of 48 adding to a positive 14. Again, to get a product of a positive number, it's going to either be a positive times a positive or a negative times a negative. And if I want the sum to be a positive number, chances are it's going to be the positive times a positive number. So thinking of factors of 48, obviously 1 and 48, 2 and 24, 4 and 12. Oh, 4 and 12 might work, but that's going to, if I add those together, that's going to give me 16, so that won't work. So start thinking of some other numbers that might work. Maybe 6 and 8. Does 6 plus 8 equal 14? Yes. So I know that 6 times 8 equals 48, and 6 plus 8 equals 14. And the last one, we got 24, positive, but the sum is negative. So again, to get a positive product, we're going to multiply a positive times a positive or a negative times a negative. But knowing that the sum is got to be negative, this is where we're going to use two negative numbers. So 24, my factors are 1 and 24, 2 and 12, 3 and 8, and 6 and 4. 6 and 4 are close, they'll get you 10, but the better one is 3 and 8. Negative 3 times negative 8 equals a positive 24, and negative 3 plus negative 8 equals a negative 11. So there are your two factors, negative 3 and negative 8. So now let's go down to some examples here. We're factoring. So let's go down to a couple examples down here. So where we're multiplying to get to 20, but adding to get to negative 12. So just like we did above, multiplying to get to 20, positive. So I know it's either going to be a positive times a positive or a negative times a negative. And I want to add to get to negative 12. So since I'm adding to get to a negative number, chances are I'm going to use this double subtraction. So my first two factors are going to be x and x. And since I know I'm using double subtraction, I'm going to start thinking about factors that multiply to get to 20. It'd be 1 and 20, 2 and 10, 4 and 5. Well, 2 and 10 I know are going to add to get to 12. And since they're both negative, negative 2 plus negative 10. Now I'm going to use this phrase called check the middles. So if I was to multiply this all out, I'd multiply x times x and then negative 2 times 10. So I know that those are going to be fine. Now I'm going to check the middle. And when I mean check the middle, I mean check to make sure that you get this middle term of negative 12. So negative 2 times x is negative 2x, and negative 10 times x is negative 12x. And if you add those together, you're going to get, whoops, this is going to be negative 10, so you're going to get negative 12x. So you know, since you got the middle term and your last two terms over here, negative 2 times negative 10 multiplied to get to 20, you know that you factored it correctly, and your answer is going to be x minus 2 times x minus 10. Let's try another example over here. So again, we've got x and x, so we're going to start with x and x. We need to multiply to get to a positive 16, but add to get to a positive 8. So since both are positive, I'm going to use 2 plus signs. Thinking of factors that multiply to get to 16, I've got 1 and 16, 2 and 8, and then 4 and 4. So 4 and 4 do add together to get 8. And I'm going to check my middles now. So if I was to distribute everything all out, x times x is x squared, 4 times 4 is 16. Now I'm going to check that middle term. 4x times x is 4x, x times 4 is 4x. Since they do equal 8x, I know that I did this correctly, and my answer is x plus 4 times x plus 4. And now since both factors are the same, you can write them like that. This is the most simplified version of it, but I'm okay if you leave it like that for now. Example C. Now what's different about example C is that you don't have a middle term in there. So what I'm going to do for now is I'm going to say plus 0x minus 100. This is what we call the difference of perfect squares. So what this means, difference of perfect squares, is that x squared is a perfect squared because you can multiply x times x to get x squared. Same thing with 100. 10 times 10 is 100, but it's a difference because we're talking about subtraction. So just like if you follow the pattern from before, you want to multiply to get to negative 100, but add to get to 0. So two numbers, like I said, 10 and 10. Well, if you have x minus 10 and x plus 10, okay, if we check, x times x is x squared, negative 10 times positive 10 is negative 100, and now I'm going to check the middles. Negative 10 times x is negative 10x, and 10 times x is 10x, and if you add them, you do get 0x, which is what we want. So you know that the factors of x minus 10 and x plus 10 are going to get you your difference of perfect squares for letter C. And letter D works the same way. I'm not sure why this is carrying with me. So let's go back and go over here. So D. So again, x squared is a perfect square, so is 49. So the pattern still stays the same, x minus 7 and x plus 7. As long as this number is a perfect square and the operation in between the x and the number is subtraction, the pattern will always follow that one is positive and one is negative. And those are level 2s. So go ahead and try level 2 and then take the quick check.